really quick. Our objective for today, I can simplify exponential expressions with fractional exponents. Read together. 1, 2, 3. I can simplify exponential expressions with fractional exponents. Julian, can you read that for us, please?
I can simplify exponential expressions with fractional exponents.
And of course, we know that our main concept still is what? Exponential expressions. That's why you already filled out your prayer model. By now, you should have a good idea as to what the definition looks like. Example, non-example, and a hashtag. So, does it look something like this? Let's see. Yeah? Sorry, I'm knowing how it feels. Something like this. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. One example, and a hashtag. All right? Yesterday we took steps. We wrote steps down as to what we're doing with exponential expressions with fractions as exponents. And I took notes in regards to each part of these terminologies, yes? Now, today I want us to fill out the summary part of your Cornell notes. Everybody knows that goes at the bottom, right? Next to the objective, okay? Now, we're going to use this question to reflect. It says, what happens to an exponential expression that has a fractional exponent instead of an integer exponent? Okay? So, at this time, write in a quick reflection in that section. In the summary section, write me a response to this question. You don't have to write the question down. What happens to the exponential expression that has a fractional exponent instead of integer exponents? I'll give you a couple minutes. Go. Copy and go. Actually, you don't need to copy the question. It should have said anything to the effect of an exponential expression with a fraction of it, using a fraction as an exponent becomes a radical, and the index is the denominator of the exponent. Something like that, right? Maybe not in those words, but somewhere in that. Yes? All right. So check this out. Next. Yesterday we reviewed prime numbers and composite numbers, yes? We reviewed prime factorization. We saw how to change an exponential expression with a fraction as an exponent into a radical. We used it with numbers and we simplified all the way, yes? We did a couple of these. We did a couple of these. Some of these, yes? And your home plate had some of these also, right? Okay? All right. I want us to get to this one. Copy example 2A. Zoom in.
In that or?
If it's right there underneath your prayer model. Example 2A. Copy that one. And you know how to do this one by yourself. I'll give you some time, and then I'm going to go over this, because this is very similar to the one in the home plate. Now I'm going to go over a couple of problems from the home plate so you can see what's going on with these. All right? Should be just about done. There it goes. First things first, what shall we do with this? Rewrite it. 81 to the 1/4 power times 5 on the exponent also. Did everybody rewrite it? Good. What's the second thing? Now we can change this into a radical. Is that correct? Radical of 81, but the index is what? 4. From there, what does this multiplication remind us? To raise to the 5th power. From there, what number times itself 4 times gives me 81? Everyone. 3. Bring down the power of 5. That becomes 3 times 3 times 3 times 3 times 3. This is 9. This is 9. What is 9 times 9? 81 times 3?
243.
It's a total of 243. Okay, hands if you got that. Okay, I'm going to go over some from the home plate that are similar to this before I move on to the next thing. Here we go. So get your home plate in front of you for those of you that struggled with some of these. I'm going to start with number 17. Number 17 shows 25 to the 1/2 times 81 to the 1/4. All right, we know how to change this to a radical, don't we? Yes, radical 25. I'm going to continue with this one till I'm done. Do we need to write the index of 2? No. That tells us what number times itself give us 25? 5. Bring down the multiplication sign. Next, can I change this to a radical? Yes, radical 81, but now the index is 4. What number times itself 4 times gives me 81? 3. What is 5 times 3? 15, and that's how you do all those in that section. Okay? I'm going to go over number 21. Number 21 was a challenge one, which is fine, but we know how to do this if we do one at a time. Okay, did I just wrap? I did, right? We will do fine doing one at a time. Bam. Here we go. We got 64 to the 2/3 power minus 81 to the what? 3/4 power plus 9 to the 3/2 power. Remember, if you do one at a time all the way through, you shouldn't have any mistakes. You would have problems because you're on problem 21. See what I did there? Yeah. All right, here we go. First, I need to rewrite this one, yes? That becomes 64 to the what? 1/3 times 2. Are we there so far? Brianna, you all right? Okay. From there, do we know what this becomes? Yes. Radical with the index of 3 and 64. What does the multiplication remind us of? To raise to the second power. Okay. Next, what number times itself 3 times give us 64? 4. 4 to the second power is 16. And we bring down the subtraction. All right. Next, I'm going to do this one. I need to rewrite it. 81 to the 1/4 times 3. Do we know what this becomes? Yes, a radical with an index of 4, yes? And then the multiplication should remind us to what? Raise to the 3rd power. All right? Next, what number times itself 4 times give us 81? 3. Bring down the 3rd power. What is 3 times 3 times 3?
27.
That's 27. Bring down the plus sign. Next, I'm going to simplify this one. 9 to the 1/2 times 3. Once again, do we know what this becomes? Yes. Radical 9. We don't need to write the index of 2, right?
And the multiplication reminds us to raise it to the power of 2.
That is correct. So from there, what number times itself 2 times gives me 9? 3. Bring down the power of 3. So what is 3 to the 3rd? 27. And at the end, we just finish this up. You guys notice that we have 0 pairs?
Yes.
This one and this one, and we're left with 16. Remember, do one at a time. Don't get too confused. Focus on one all the way through. Bring down the operation. Focus on the other one, and then the other one. Okay? All right. Let me go over one with the formula, because I know some of you struggle with that one. Look at number 20. Damn, number 23, Michael Jordan. They give us the formula T for time equals to 1/4 times D for distance to the 1/2 power. Now for number 23, they give us 36 feet. Question. Feet. Is that time or is that distance? Guys, feet. Is it time or distance? So instead of substituting in the T, I'm going to substitute in the D. So it's 36 to the 1/2. When these are side by side, it's multiplication to the 1/4 equals to T. All right. Now, on some of your papers, I wrote use order of operations. Yes? You guys remember order of operations since elementary? Please excuse my dear Aunt Susan. You guys remember that? No? You guys remember that? Sally? Oh, I don't have a Sally. I have a Susan. So you start with, check this out, for those of you that forgot, you start with parentheses. Anything inside of parentheses, so we don't have a parenthesis. Next, we do what? Exponents. This is for expressions, guys. Next, we do what? Exponents. Do we have an exponent?
Yes.
Yes. That means we need to focus on this one. Do we know how to change this one?
Yeah.
Square root of 36. What does that mean? A number times itself to give us 36, which is 6. Bring down the multiplication. 1/4 equals to T. Do we know how to multiply these at the end? Multiplication, division, yes. What is 6 times 1? 6. What is 4 times 1? 4. Can we simplify this? Yes. 4 fits in there 1 time and 2/4, which is
1/2.
1 1/2 seconds.
Or you can do 1.5.
You can do 1.5. All right. Any questions with those? And that's how you do the others. Just make sure you follow the order of operations. Last but not least, look at this one, number 27. They give us the formula C equals, parentheses, A squared plus B squared to the 1/2. And for 27, they say that A is 5 and B is 12. So here I'm going to substitute. A is 5 plus B is 12, parentheses to the 1/2 equal to C. We follow order of operations. We do everything in the parentheses. What's in the parentheses? What is 5 squared? 25. 12 squared? 144. What is this? 169. Bring down the power. Do we know how to change that? Yes. That becomes what? Square root of 169. What number times itself give us 169? C equals 13 inches. Some of you are dividing. I don't know why you're dividing. You need to change this to a radical. That's what the lesson was about. And that's how you do the rest. Okay? And of course, the properties, you need to review those by yourself. Okay? Let's move on. Do this one by yourself. Example 2C. By now, you should be able to do that one. Example 2C. Let's see what you get. So we can move on to funner stuff.
Yay, fun.
Nerd. Copy that and go. 1 minute. All right, share with me. See what you got. Correct answer is 8. Here goes the process one more time. I need to rewrite this. 16 to the 1/4 times 3. 16 to the 1/4 becomes a what? A radical 16 to the index of 4. Raise that to the 3rd power. So what does that mean? One number times itself 4 times. Give me 16. 2. Bring down the 3rd power. What is 2 to the 3rd? 2 times 2 times 2, which is 8. Follow the process all the way through. Okay? All right, now that we're done with the easy part, you guys ready for the funner part? Yay! Copy this one. Turn your paper over if you don't have space. Example Q. Hold on. Let me make this bigger. All right, writing utensils down, look up to the screen. Now we have a dilemma because now we have an exponent on the variable. But if we follow the same process that we did with numbers, it works the same. Look up. This says that a number times itself. You ready, Julian? You're holding everybody 30 seconds behind now. Okay. What number times itself 3 times gives me this radicand? Since we cannot simplify the variable, that means the variable or the root is going to have the base of x, which means it's x, x, and x, but now we need exponents, right? Once again, what exponent goes on all these 3 to give us x to the 12? Talk it over with your neighbor, please. Hunter. That is correct. 4, 4, and 4. If we're multiplying, what happens to the exponents? We add, right? What is 4 plus 4 plus 4?
12.
So that's how we get that. Let me show you another one. There. All right. So how many times does it multiply itself? 1, 2, 3, 4, 5. That means that my base is the same, right? So tell your neighbor the exponent of all these to get my root. Correct answer is 6. That's how it works. However, is there a shortcut? Yes. Look up, please. Those of you that already saw it. Tell your neighbor the shortcut, please. Copy that, please. As you're done with that, copy this next one, do this next one by yourself. Example super Q. Let's do cube root of a to the 6 and b to the 12. Copy that and go. Brody, what'd you get for example super Q? Hands if you got that. That is correct. Okay. Crank it up a notch. Example mega Q. Let's do cube root of 8, x to the 9, and y to the 18. You're like, that looks a little different, I know, but you know how to do each piece by itself, right? Follow your instinct. You already have the pattern.
Once we're done, do you put it away?
No, we're missing one more. Remember you slowed us down on that last one. Hands if you got it. Okay, here it goes. One number times itself 3 times give us 8. 2. All right, and what happens to these? Divide x to the 3rd and y to the 6th. Hands if you got that. Okay, last one. Here it goes. Example Shazam Q. Check this out. Cube root of y to the 7th. There's a dilemma here, isn't there? So watch. I rewrite it. Do you agree that this is this? Yes, so therefore, do we know how to simplify this one first? That's y to the what? 2nd. So we're done with this one, right? Which is the only one we can't simplify? This one, so we leave it in a radical form. Cube root of y to the 1st. Okay? All right, so your home play for tonight is on page 34, all, only. Also, write this one down. 4th root of a to the 20th, b to the 24th, and c to the 1,000. Just add that one to your home play. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye. Tutoring. There is tutoring for free. All right. Have a good one. Bye.